think that might actually be the heat coming on. Let's hope. Let's hope for the best, guys. Let's just be good kids and do our work until the school blows up. Nathan's like, what is going on? Because I just started recording. Now, we heard a weird noise, Nathan, and we've decided that it was probably a rocket. All right, dependent events. So remind me what independent events are. Yeah, just flip the page. What are independent events?
Two events that don't affect each other.
Right, so what are dependent events?
Two events that do affect each other.
Always. So 2 events or more that always affect each other. One is dependent on the other. Can you think of 2 things that definitely affect each other?
The weather and footwear.
Sure. It's kind of what we talked about before, right? All right, always is kind of a touchy word there. Does everybody end up wearing boots in the winter? No, for sure not. We have quite a few kids in this school who like to wear shorts, right, in the winter all year long. But it is overall, like if I looked at the stats of the school, yes, weather will affect the footwear for sure. All right, now we get to decide if these are independent or dependent. Do you guys want to do this? Oh, let's do it together. This selecting a king from a standard deck, not replacing it, and selecting a queen from the deck. What do you think? Independent or dependent? Will the first thing change the probability of the second thing? Yes. Why?
Because you start with 52 cards, but since you don't replace the king, you only drop down, or you drop down to 51 cards.
Yeah, so I'm going to write 51 above the queen because there are 51 cards total at that point. Tossing a coin and getting ahead, and then rolling a 6-sided dice and obtaining a 6. Independent or dependent? What do you think? Independent, yeah. Nothing to do with each other. You might be very lucky when it comes to flipping coins. Nothing to do with rolling dice. Driving over 85 miles per hour and getting into a car accident. Independent or dependent?
Dependent.
Dependent. Are you guaranteed to get into a car accident if you go over 85 miles an hour?
No.
No, but it's more likely. All right, why don't you talk to your partner, decide on the next 2 whether they're independent or dependent. Go ahead. Everybody done? Okay. What did you guys think on 5A?
Dependent.
Dependent. Are you guaranteed to get emphysema if you smoke a pack of cigarettes a day? No. Is it more likely? Yes. Tossing a coin, getting a head, and then tossing a coin and getting a tail. The same coin.
Independent.
Now, what's the difference? Because before, we were selecting a king from a standard deck of cards, not replacing it, selecting a queen from the same deck, and that one was dependent, where here we're flipping a coin, the same coin twice. This one's independent. What's the difference?
The probability on either flip doesn't change at all, so the first flip doesn't affect the probability of the second.
Right, and on the first one, we had a deck of cards and we threw away one of the cards, right? So that changed how many cards were in the deck. It's not like once you get a heads, it's like, okay, now you're not allowed to get a heads anymore. If that was the case, it would definitely be dependent, because you'd have to get a tails the second time. All right, so the multiplication rule is the probability of A, I'm gonna write this capital letters, and B happening is the probability of A times the probability of B. So if you want two things to happen together, you multiply them. Two cards are selected without replacing the first card from a standard deck of 52 playing cards. Find the probability of selecting a king and then selecting a queen. Okay, so it's something times something. First, we're talking about a king, and then we're talking about a queen. What's the probability of getting a king?
4 out of 52.
Good, 4 out of 52. There's 4 kings out of 52 cards. And then you throw away the king. Now what's your probability of getting a queen?
4 out of 51.
Mm-hmm. And we're going to multiply those together. Do you guys remember how to multiply fractions?
Absolutely not.
You multiply the tops together and the bottoms together. So 4 times 4 is 16. On the bottom, I'm going to need a calculator for this one. So should you if you don't have one. I got 0.006. So less than a 1% chance that you would select a king and then select a queen. So the bottom number was 52 times 51. So, however, what if I said to you, I just want to get a king and a queen. I don't care what order I get them in. But I'm still doing the throwing away stuff. That means this probability that we figured out was just me figuring out a king and then a queen, right? Now, if I figured out instead the probability of me getting a queen first and then a king, that would have been the exact same thing again. Do you guys agree? But since either thing could happen, I'd have to add them together. So that would make 1.2% instead of 0.6%. We can talk more about that one later. How about this one? A coin is tossed and a die is rolled. All right, so we got a coin and a die. So and means multiply.